Okay, so we're moving on to more trig, and this one's called more than right, and you'll see why it's called more than right in a second. So today we're going to be able to find missing sides of and angles in non-right triangles. So let's review really quick. When oh, okay. So it says so reviewing right triangles. Whenever you see a right triangle, so then go back to the previous lesson, there are two paths that you can possibly take whenever you see a right triangle. What are those two paths? I've said this before. What are the two paths that you're probably going to use whenever you see a right triangle? Very good. Trig and Pythagorean theorem. So in the previous example we just did, we used trig. Okay. We could have actually used a combination of trig and the Pythagorean theorem if we wanted to, but my preference, I'll just tell you right now, is always going to be trig. Now, Ms. Johnson, when do I use trig versus when do I use the Pythagorean theorem? That depends on what they give you. That depends on what they give you. If they give you angles and some sides, most likely you're going to be using trig. If they only give you sides, most likely you're using the Pythagorean theorem. If you're looking for angles and they didn't give you any sides, or sorry, and they gave you sides, most likely that's trig. So trig, sine, cosine, tangent, that's where sides and angles work together in an equation. And that's kind of the first place that that happens, right? In every other like equation that you know, like the sum of the angles of a triangle, those are all angles. Angle plus angle plus angle equals to 180. If you're talking about the Pythagorean theorem, that's side plus side plus side, right? Though we're talking about sides. So trig is the first place that you actually get these two to combine into one equation, which is really neat, right? Okay, so here's the question. How can I use trig and the Pythagorean theorem to find the lengths of sides of non-right triangles? So that's what our task is for today. We're going to be looking at non-right triangles. And there's a couple like strategies that you're going to see me use over and over again today. So keep those strategies in mind. So here's where geometry is very different than algebra. Algebra is I'm going to show you how to do one problem and you're going to use that problem, you're going to use that strategy over and over and over again. In geometry and trig, that's not the way it goes. The way it goes is you have all of these tools, like pretend that you are a handyman, and you have all of these tools, right? You have all these tools: hammer, screwdriver, drill, table saw, sander, and then you have a problem in front of you, and based on that problem you're going to pick out the appropriate tool, right? You're not going to use a hammer to screw in a screw. That doesn't make sense, right? So you're going to have to look at which tools are available to you, what problem you have, and then be able to go forward. I'll make a little bit of a list for you so it's not so gigantic. All right, here goes. So we can use right triangle trig and Pythagorean theorem to solve for missing triangles or for missing sides and angles in a right triangle. But what about other triangles? How might we find unknown sides and angles in an acute or obtuse triangle if we only know a few pieces of information about them? Whenever they talk about few pieces, they're talking about sides and or angles. In the previous task, we found it might be helpful to create right triangles by drawing an altitude in a non-right triangle. We can then apply trig or the Pythagorean theorem to the smaller right triangles, which may help us learn about some about the sides and angles in the larger triangle. So what did we do? We drew an altitude. So in case you don't know what an altitude is like if you had a triangle, pretend that you're in a building and it's a like, I don't know, it's like a weird shaped building. Okay. That looks like a funny building. Judge me. It's okay. So in the building, you decided that you are at the tippy top right here, and you decide to let down your rope that has a weight that's pulling it down. So that rope is now considered your altitude because things fall through gravity and it will fall perpendicular to the floor. I'm going to say that again. Whenever when you drop something, not when you throw something, because that doesn't fall perpendicular. When you drop something, its path falls perpendicular to the floor. Okay, so that's going to be our altitude. That's what they mean by altitude. Okay, are there any other words here that you're like, not sure? You should know Pythagorean, you should know trig. Non-right triangle is okay. If so, ask me so we can make sure that we're good. Okay, so see if you can devise a strategy for finding the missing sides and angles for each of these triangles. So given this is an acute triangle ABC. So wait, what does this guy mean? What does acute mean? Anybody remember what acute means? What does acute mean? Yes, very good. It means, so an acute angle is when the angle is less than 90 degrees. So an acute triangle means that all three angles are less than 90 degrees. Hence, you do not have a right triangle here, okay? So for those of you who are like, cool, this is a right triangle. No, it's not. Ms. Johnson, how do you know it's not a right triangle? Number one, I don't see a right angle. And number two, if I add these two together, 40 plus 65 is 105. So this is 75 degrees. So I just proved to you that this is not a right triangle. Some people say, oh, but Miss Johnson, it doesn't look like a right triangle either. Unfortunately, Miss Johnson does not draw very well. Okay. So if I draw a triangle like this and then I stick a little right angle symbol in there, guess what? It's a right triangle. In geometry, you can't say, oh, it looks like it, therefore it is. You have to go off what it truly is. So I'm going to pause this really quick, and your job is to find the missing sides and angles. We already did that for these triangles. So I want to know what we know what A is. I want to know what B is, and I want to know what C is. A little side note, just in terms of geometry's sake, just so that you guys are like, I want you to notice this as well. This is something that you should notice as a pattern. Geometry, we usually label things according to, okay, capital letters are reserved for points. So this vertex is labeled with a capital A because it is a point. Lowercase letters are reserved for lengths or different things like that. So I'm going to label this length AB as the lowercase letter C. The other thing that you should also notice is that big C is always going to be across from little c. Just like big A is across from little a, big B is across from little b. Does that make sense? So these are what we call conventions. They're not strict rules, but you'll see this happening over and over again. And it just helps to know so that you're comfortable with those patterns. Okay, so I'm going to pause it really quick so that you guys can take care of this. You're going to have to find a strategy. Maybe you use the strategy from the previous slide and to find what makes sense. Okay, so I'm going to pause it. Okay, so for those of you who are stuck, we're going to take the strategy from before. It says, in the previous task, we found it might be helpful to create right triangles by drawing an altitude. So we need to draw an altitude? Yeah, you need to draw an altitude. So the way you draw an altitude, and it's easier for me to do it off of here. So let me go here. So when you're drawing an altitude, the easiest way to go is first determine which side you're going to make as your base. So if you're going to say this is your base, that's great. So then kind of like turn your head so that this is horizontal and then pretend you're at the, tippy top of this building and you're going to drop that rope so it's perpendicular to it. You guys kind of see how it's perpendicular? Okay. So I'm going to draw a line and it's going to go like this. So it's just easier. So I think it would look like that looks perpendicular. So it looks like this, but then I need to scooch it over. Oh, it's darn you, snap to grid. All right, I'm just gonna ignore that then and draw my own. All right, so there's my altitude, right? And I'm going to tell you that this is my altitude by doing this. I can't go off looks, so I need to tell you this is an altitude. So now I'm going to just label this as H, because H usually means height. And so now I've changed this acute triangle into what? What do you see here? What do you see here? So for those of you who don't know, you really, really want to go for your observation. Don't do the lame thing where, like, oh no, it's obvious to everybody. No, it's really not. It's not obvious to everybody. So yeah, you're right. And can you guys practice chatting publicly? Very good. You should see right triangles. Now, here's the question. Do you see your special right triangles? Do you see your special right triangles? Anybody see your special right triangles? Do you guys know what I mean by special? That's this guy. Oh, where'd he go? There he is. So either this guy or the other guy. So I don't see 30, 60, 90. Some of you are like, that one kind of looks like it, Miss Johnson. But he's not, because he's a 40. I don't have a 40, 60, 90 triangle. That's not a triangle, right? And I don't see a 45, 45, 90 triangle either. So I'm not dealing in special right triangles. So this guy is going to go away. So you have a choice now. Because we're in right triangle land, there's two paths. I'm going to keep saying this over and over again because I want it in your head. There's two paths that you could walk down. What are the two paths that I could walk down? Very good. Trig or Pythagorean theorem. Okay. So let's see. Can we use the Pythagorean? I know you guys are all more comfortable with the Pythagorean theorem, so I'm going to start there. Can I use the Pythagorean theorem on these triangles? Now, some of you need to take these two triangles apart and move them away from each other. Okay. So some of you need to take these two apart and like ignore the rest of them. So I'm going to do that. I'm going to go like this. I'm going to draw this guy over here. And they're not going to be perfect drawings. It's just going to be drawings that I can recognize. Oh, that one's that one. So some of you need to draw this out. So this is C, A, this is B, this is 10, this is H, this is H, this is B, this is... So now I can't say this is C. Okay, I cannot say that this is C. C is this whole length from A to B. So I can't say that this is C. So I'm going to make these, I don't know, other letters like X and Y. Okay. So, and then I'm going to draw my little right angle in there. What else? What else am I missing in my triangles? What else am I missing in my triangles? What else am I missing? What else did I forget to copy? Yeah, I forgot these angle measurements. Angle measurements are huge because they're going to help me do some stuff. So I'm going to put 65 degrees and I'm going to put 40 degrees. Now that I know that, I'm going to put 50 degrees and I'm going to put, what is this, 25? Yeah, 25 degrees. I already found this out from earlier. I think we said that this was going to be 75 degrees. So I'm going to put that there. Everybody okay with that? Yeah, always label your triangles. So when I say the word solve your triangles, it sounds funny, but I basically want you to find all sides, all angles, everything. I need to know everything. So the reason why I separate these two triangles out is because it gets too cloudy, too busy in here. So I'm going to go up to my two triangles and say, hey, can I use the Pythagorean theorem on you? Hey, can I use the Pythagorean theorem on you? You guys say yes or no? Yes, no. Can I use the Pythagorean theorem on this triangle over here, the right side? People say yes or no, yay or nay. Yeah, no. Why not? Why can't I use the Pythagorean theorem here? And the answer is not yet. right? The answer is not yet. Yes, I only have one side. In order to use my Pythagorean theorem, I have to have at least two sides, right? Because my Pythagorean theorem is going to go a squared plus b squared equals c squared. So that's going to say h squared plus y squared equals 10 squared. Do you now know more information? And you're like, no, I don't know. I don't know h and I don't know y. So clearly, if I can't use Pythagorean theorem on here, I clearly won't be able to use it here. Is everybody comfortable with me so far? Okay, so let me walk through what we just did. Number one, I separated out the triangles because it gets too cloudy here. Later on, when your eyes are used to looking at this, you won't have to do this. Okay, this is the equivalent of before, like, hey, what's 5 times 5, Johnny? Johnny goes, 5, 10, 15, 20, 25, right? He will eventually let this go because he just now knows and he's comfortable with the fact that 5 times 5 is 25. So right now, I'm giving you it's called a scaffold, a strategy that will train your eyes to see this. But right now you can't, so I'm going to separate them out for you. So I can't use Pythagorean theorem, Ms. Johnson? No, not yet. Okay, not yet. So then I have to use trig, Ms. Johnson? Yes, I have to use trig. So here's us reviewing trig. Okay, so I'm going to review trig. I'm going to go, this is going to take me to the side just a little bit. I'm going to go off on a little bit of a tangent, pun intended. So whenever I'm dealing with trig, I'm asking you a couple of things, okay? So in trig, we like to use Greek letters. So this is the letter theta. Everyone say theta. Theta. It's the letter that makes the sound in Greek. That's all it is. It's just another letter. It's just not one of our, alphabets or letters. Okay, so the very first thing that I'm going to do is I'm going to label everybody's side according to theta. According to theta. So theta has the hypotenuse, which this is everybody's hypotenuse no matter what. And I think I spell hypotenuse wrong every single time. Someone look this up. Okay, the next thing I'm going to do is I'm going to label these two sides. Now, one of the sides is called adjacent. Adjacent means next to. So if you think about what room is next to your room, so everyone think about the room that you're in and point to a wall and be like, oh, the bathroom is adjacent to this room. So if I could go through this wall right here, it would be the bathroom. I spelled it right. Woo, woo. Thank you. And if I go this way, oh no, go behind me. Sorry. Behind me is my son's rooms, right? So this way, bathroom, it's adjacent to it. This way, adjacent to it. Okay, so this is called adjacent. So I'm going to say theta's adjacent side. So really, I'm just going to say adjacent. But I don't want you to think that this is the adjacent side for everybody. Because over here, this guy here, whatever letter I'm going to make him, if you want to do alpha, looks like this. This is like, he needs to look better than that. But alpha is the lowercase letter a in Greek. It's no longer his adjacent, right? That's not his adjacent. So just keep that in mind. That's why I put theta's adjacent. All right. This guy here would be called opposite. Opposite. So again, this is theta's opposite. So the reason why this is theta's opposite is because he's across from, like, think about if they were playing chess, they'd be opposite from each other. Maybe they're playing football and this is the defensive line. This is the offensive line. They're facing each other. Does everybody see that? I like to draw like a little arrow. Hold on, let me get my little arrow just to show you, like, it's opposite. Does everybody see how that's opposite? Opposite. This is the most important part. If I can spend a little bit of time here, then by the time I get over here, everyone's like, yeah, that's clearly the opposite. So if you don't remember from before, here's your little review. Adjacent means next to. In fact, it's one of the sides of the angle. Okay. Opposite is the guy across from. Okay. All right, moving on. So then we go back to, then the other part that I needed you to remember is SOHCAHTOA. Hands up or in the chat, tell me if you remember SOHCAHTOA. SOHCAHTOA. Yes, kind of, sort of. So if someone says, yep. Yes. Okay, good. So SOHCAHTOA means sine, cosine, tangent. So for those of you who don't know this, I'm spending a little bit of time because, again, if I spend a little time here, it's going to pay off for the rest of this chapter and the next 2 chapters. Okay, this is literally one of those things. So if I wanted to find the sine of theta, now this is important. I get students writing this wrong all the time. They'll put sine and then they'll put the side. What goes into sine is angles. What comes out of sine is the sides. I'm going to say that again. What goes into sine, I'll draw it like this maybe. What goes into sine is angles go in. It's their input. It's part of the domain. That's what I'm trying to tell you. And then what comes out is the sides. This is the range. So I get students all the time who, let me scroll up a little. I get students all the time who'll say sine of x, and this is where x is. No, you just told me you don't understand sine. You just told me you don't understand sine. They'll say, oh, and some of them won't even put a thing in there. They won't put anything inside. You not putting anything inside of sine is like you going like this. Hey, what's the square root? And you're like, square root of what? Notice you have to have something that goes into your square root. You need something that goes into sine. So what goes into sine are the angles. So sine of theta, sine of 40, sine of 50, sine of 25, sine of 65, sometimes even sine of pi, right? What comes out of it is, it's actually not just sides, it's actually the ratio of sides, but we'll leave it right there. Actually, ratio of sides. Okay. So then what is sine? Do you all remember how to figure out sine? How this helps you? Okay. Sine is opposite. O stands for opposite. H stands for hypotenuse. So I'm going to find the opposite. O, the opposite, and then hypotenuse. And I'm just going to write it like that. Yes. That's how you find sine. Cosine is the same, except for now we are using adjacent. Tangent is the same, and it's opposite over adjacent. Don't ask me why, but sine is my favorite. I don't know why. I think it's because I learned him first. He's the most useful. I'm not sure, but sine is my favorite. So I'm going to have you practice. I want you to find the sine of B. Find the sine of B. So I'm going to write it over here. I want you to find the sine of B. Actually say this in your head. Say, I'm going to find the sine of B. And write sine and then big B, right? And then I'm going to make this a little bit smaller so you can see both things at the same time. That's good. And I want you to find the sine of B. I don't want you to solve anything. I just want you to find the sine of B. Now, some of you are like, Miss Johnson, since B, the measure of angle B equals to 65, can I write 65 there? Yes, but right now I just want you to practice writing the sine. So sine of B. I'm going to give you 4 more seconds, 3 more seconds. Actually write it. Don't wait for others. This is not the time to like, oh, I'll just wait for her to do it. Don't do it. This is one of those things I keep telling you. It's gonna pay off. Someone told me something really good earlier today in my first period. I asked them for advice for my freshmen who are struggling with doing homework. And she said, her older sister says, your effort is going to be reflected in your future. Your effort will reflect itself in your future. Or I think she might have said, your future reflects your effort right now. Either way. So this is one of those things that it's going to pay off. I'm going to know for a fact that you get this. Okay. So sine of B equals to what? What did you guys get? What does sine of B equal to? What did you put in the chat? What did you put? Someone said 25 over 10. No, nice try. 25 is an angle. So it can't go as your opposite, right? Your opposite, you're going for the side. So I'm going to draw a little arrow. You should too. Take your angle, start at your angle, and then go to the opposite side. So that's H, right? So some of you wrote H, H over, and then your hypotenuse, which is 10. Good? H over 10. If you don't remember this, you're going to have to practice this. I promise practicing this will definitely help. So, yeah. So H over 10. Opposite side over hypotenuse side. So again, the angle goes inside, the ratio of sides come out. You're like, just get used to hearing that. So if someone says sine of this 10 right here, if someone says sine of 10, it should feel as funny as someone saying, I ain't got no money, or something like that, where academically that's not sound, we don't say that in academics, right? Okay. So one more time, sine of b equals to h over 10. If you didn't get h over 10, fix your mistake. I saw someone in the chat go, oh, I see where I made my mistake. Someone else said, oh, I got it. Good. I have $0 in my bank account and I got no money. Exactly. Perfect. Okay. So everybody okay with this? So the next thing that I would have you try, this is us just practicing writing sine and cosine. I now, for some reason, want you to write the cosine. So instead of writing cosine of b, I'm going to have you write cosine of 65 degrees. So you practice, write the cosine of 65 degrees. So I'm practicing this with you. This is something that you were supposed to come knowing how to do, but I already know that if I talk about it now, then it'll pay off later. So I am going to take the time to do this. So cosine of 65. So this is redemption time for those of you who didn't get it right the first time. Yeah, so when we're finding cosine, we're going to be using ka. So A stands for adjacent. H stands for hypotenuse. You got to grab the adjacent side and put it over the hypotenuse side. So what did you guys get? In the chat, can you tell me what you got? In the chat, tell me what you got. I've got 1, 2 people with the right answer. I've got 3 people with the right answer. 4, 5, 6, 7, 8, 9, 10. Yeah, all of you are right. Every single person who put something in the chat is right. Very good. So I'm going to move on. If you didn't put your answer, why not? Right? Why not? So cosine of 65. So the very first thing I do, just to review, I go to my 65 and I'm like, cosine is ka. So cosine is adjacent. Who's adjacent to my 65? And so some people say that 10 is adjacent. He is adjacent, but he's more known as a hypotenuse. Okay. So adjacent side is going to be y. So y over 10 is my answer. All of you got that. Every single person who put that in the chat got y over 10. Perfect. So I can continue, but I'm not going to. I am now going to move on. Tangent is the same thing. Tangent means opposite over adjacent. For some reason, not my favorite. The most useless one to me for some reason. You'll understand why later, but for me, sine is the most important one. If I know sine, if I just remember OH, opposite over hypotenuse, I can get through 85% of the problems that we have. Because if I can't find the sine of this guy, then I can jump to the other angle. Probably can find it. But let's see. Okay, so now how do you actually solve for y, Ms. Johnson? Like, what do you do? Now, this depends on what kind of calculator you have. Since most of you are going to use Desmos, I'm going to be teaching you off of Desmos. If you have one of those handheld calculators, you're going to have to do the same exact steps, except for you might have to enter things backwards depending on how your calculator is built. So the very first thing that I'm going to do is I am in degree mode, correct? So then I need to go up here to the settings. So everybody, I'm going to like pause so that you guys can do this, because you're going to put it in and it's going to be completely wrong. And your answer is going to look really right. Yeah, exactly. Very good. Someone said, hey, Ms. Johnson, why? Because it's next to the 65 degrees. Exactly. Exactly. Okay. So you're going to go to settings, and then you're going to see right now it's clicked as radians. We will be using radians later, but it's defaulted at radians. So because we're in degree land, we need to click on degrees. I'm not going to click on it so I can show you how wrong it'll be, but it'll look right. Have you ever done something and it looks right, but it's wrong? But you're like convinced that it looks right because it looks right. So this will pop out answers for you and it'll be completely wrong. So go ahead and click degrees. I'm going to hit cosine of 65 and see what I get. It gives me this negative number, which is really strange. It gives me this negative number, which is very strange. This is actually counting 65 radians, right? A radian is how we measure, is an alternative way that we can measure angles and stuff like that. So see how it pops out an answer, and it's an answer. It doesn't look wrong, but check this out. When I change it to degrees, dun, 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 is it still going to give me the same thing? And the answer is no. Oh, darn. It changed it. It changed everything. So it was negative before, and now it's positive 4.22. It's now positive 4.22. Okay. So notice here you have to click on degrees. If you're using one of these calculators as well, where's my calculator? Like just your computer calculator. Just make sure that it says degrees in the little corner. Wow, it's taking really long. Look at that. Oh, there it goes. So here it's in degree mode. It says DEG. If it's not, it'll say radian, RAD, rad. So it's already in degree mode. So this is, you have to enter this in backwards. So I'm going to hit 65. It doesn't have a sine button or cosine button. So I'm going to have to hit trig. And then I hit cosine. Don't worry about these other guys. We'll talk about them later. And it gives me the same answer. Dun, dun, dun. Okay. And it gives me more digits because this apparently holds more or shows more. So I'm not going to pull off this number and round it because I'm a mathematician. I'm actually going to encourage you all to solve for y. So right here, if I wanted to solve for y, how would I get rid of this 10? If I wanted to solve for y, what would I do with this 10? How do I get rid of it? Yeah, you just multiply by 10. Very cool. I'm going to put the 10 all the way out in front up here, right? Because I don't want to confuse my reader, the person reading my answer, to like, hey, is this 65 times 10, then take the cosine? So I'm going to put it all the way out in front because then that's going to be clear that I'm multiplying 10 times the cosine of. So order here matters. So I'm popping that 10 all the way out in front like it's a coefficient because it is. And that means I can just put a 10 in front of here. Your job, especially for those of you who are going to be engineers and stuff, your job is to hit enter stuff into the calculator once, because every single time you hit stuff into the calculator and you round, that error is just getting bigger and bigger and bigger, which could cause some major stuff. So 10 cosine 65 is equal to, did I hit enter? 4.2, I'll just go with 4.26. 4.226. Okay, so y, now notice here I'm using approximately 4.226. Everybody comfortable with this? Any questions on this? Ms. Johnson, how did you enter it in the calculator? Right here. Just make sure that you hit the what button? Very good, the degree button. Ms. Johnson, how did you get rid of that 10? I just multiplied by 10 because that's the inverse of dividing. Shelton, why'd you put 10 all the way out in front? Because I don't want to confuse my reader to think cosine is 65 times 10. So I'm just going to show you cosine of 65 times 10 does not give you the same answer. Because PEMDAS is telling them to like calculate 65 times 10 first and then take the cosine of it. That's why we pop them out all the way out in front. Okay, so this is wrong. Wrong. Did you have to use approximate symbols? Yes, because we're not, unless you want to write down all those numbers and the numbers go on forever. So no, I'm going to use this. Okay, so now I'm going to have you practice. So now I want you to find h. Now we already have an equation for h, but you also have options. Remember earlier I told you, we can't use the Pythagorean theorem yet. right? Some of you are really comfortable with that, so that's going to be your option. Some of you who are going to be big and bad and bold, you're going to try to do this, and that's what my suggestion is. Now I would like you to find H. So go ahead and take a couple seconds and find H. Okay, so my suggestion to you was to use this. You could have also used this, but I'm going to push you towards understanding. So the very first thing that I'm actually going to do is I'm going to multiply both sides by 10 because that's mathematically what I want to do. So then I'm going to say H is equal to 10 sine 65 degrees. Notice here, this is equal to. But the moment I plug it into my calculator, I'm now going to get rid of that equal to, right? And I'm just going to put sine instead of that. So my answer was about 9.063, which is what you guys all said. H is about 9.063. So once I get enough of those here, I start labeling my big diagram so that it's going to help me. So this little guy here is 4.226. And now my H, I can erase and put as 9.063. Oh, that means this guy, equals 9.063 as well. And you guys all know where we're going to go next, right? So now that we have 9.063, we've hopped over to the other triangle because this triangle pretty much was blank. There was nothing else I could do because I didn't know any of the sides. So now that I know one side, I can now actually find all my sides. Okay. So can you write me an equation to find either B or X, or write both? Can you write me two equations like we did here? Cosine of 65 equals y over 10, sine of b equals h over 10. Just make sure you're putting the things in the right spots. Okay, you could have used either, notice I didn't even touch 25 degrees. I could have if I wanted to, but I didn't. So you're going to write two equations that would help me find b and x. So go ahead and do that. Once you're done with that, I need you to solve each of them and then do that. Yeah, someone said, can we use tangent, Miss Johnson? I know you don't like it. You get to like whatever you want. I don't know why I have a preference towards sine, but I do. So go ahead and write two equations that would help me find b and x. So pop that into the chat. What's one of the equations that you used? Yeah, no. So if you're going to use tangent, right? If you're going to use tangent, notice hypotenuse is not in the mix. Yeah? Hypotenuse is not in the mix, right? So if I was going to use tangent, I guess I'll use tangent. I'll write it for that one. Let's do tangent. I'll write it over here. Tangent of 40 degrees is equal to 9.063 divided by x. Opposite over adjacent, right? So notice here, I didn't even touch your hypotenuse. So the opposite can't be the hypotenuse unless you're going from 90 degrees, right? So the opposite of hypotenuse is your 90 degrees, and you don't, when you're solving triangles, you don't want to use tangent of 90 degrees or sine of 90 degrees. Yeah. So one of your options was sine of 40 equals this, and now you can solve it. Some people are like, wait, Ms. Johnson, the x is on the bottom. I'll show you how to do that in a second. Let's grab our other equation. What equation did you use for b? Someone said sine. I'll try that. Someone said sine of what? What are you going to do sine of? Sine of 40 or 50? Oh, 40. Okay, sine of 40. Very good. If I used sine of 40, it would not help me, right? Because look, sine of 40, sorry, did I say that wrong? I did say that wrong. Sine of 50 wouldn't have helped me, right? Because that would have been x over b. x over b, unless you found this first and then moved it over here, which that's fine too. So I put 9.063 over b. All right, so let me finish this up because we're almost done. If you want to solve for x, there's a couple different ways you could do it. The way that comes straight to my brain, what's a way for you to solve for x here? How do you guys solve this? I'll give you a couple of different options. You guys choose which one you like the best. How do you solve for x here? What do you do? Yeah. So if some of you, I don't know, for me, yeah, I don't like fractions. So whenever I have fractions in the equation, I'm always going to multiply by the least common denominator. In this case, my denominator is x. So I'm going to multiply both sides by x. Remember, we always put them in the front of your trig functions. So then x divided by x is 1. And I get 9.063 and then x tan 40. Okay, this is the weird part that people like see this as weird. Okay, so pay attention 2 seconds and then you're all gonna go, oh. So in between x and tan is multiplication. So how would you get rid of tangent 40? Now see this as a number. Like this is, I don't know, 2 something, 1 something. I don't even know what it is. 1 something. Right? How do you get rid of tangent 40? What would you do? Since this is x times that, what would you do to get rid of it? Yeah, very good. We divide. So divide by tangent 40, which feels weird. Everybody feel the weirdness of it, but it's still a number. Don't treat him any different. People like to treat him different because he looks like a different number. He just looks different. Don't treat him different. So x is equal to 9.063. Technically, those should be approximate symbols, by the way. The reason why they should be approximate symbols is because 9.063 is an approximate, but that's okay. We'll leave it right there. Okay, then I'm going to take this over to my calculator and I'm going to do this. Notice here, if you really wanted an accurate answer, you could take this whole thing and divide it by whatever, but I'm not going to do that just so that you're feeling comfortable. 9.063 divided by tangent. I already know that I'm on the right setting, but I'm going to check anyway. I am. Tangent of, now see this little exclamation point? It means you did something wrong. You can't divide by tan, but you can divide by tangent of 40. So my answer is 10 something. My answer is 10 something. So x is approximately 10.801. So where does that guy go? That guy goes right there. 10 point. Okay. And then last but not least, you would do the same thing to find B and then pop B over here. Then you're pretty much done. To find C though, you would have to add these two numbers together, right? 4.226 and 10.801 for a total of 15.027, something like that. All right, so figure out which is the hardest part for you, which part do you not like, and practice that part. Is it writing the equations of sine and cosine? Is it actually not, Miss Johnson, I'm good on writing it because look, I got y over 10. Is it actually solving it, like multiply by 10 by both sides? Or, multiplying by the reciprocal here. Someone said multiply by the reciprocal, that works too. Is it actually plugging it in and remembering to hit degrees? A bunch of you are going to hit the wrong button during a quiz. Just remind yourself, put it somewhere that's obvious that will remind you. Whatever the part is, there's no part here that I'm like, I like to ask this question to my students. Hey, what's the hardest part here? Like, what's the part that's going to make you fail on a quiz? And someone's like most of you are going to be like, there's no hardest part. It's just remembering, what everything means and how to find it. So whatever makes the most sense, make sure you practice it. So thank you for listening.